Alright, inorganic nomenclature. Alright, actually naming some of these formulas that we are seeing around. This should be just a review from your Chemistry 1 class, so hopefully we'll speed this process up, and you will be a master at naming different compounds by the time you finish. First thing that we're going to do is we're always going to write the name of the cation, typically a metal or the positively charged ion. If the anion is an element, meaning we have a binary compound, change its ending to IDE. If the anion is a polyatomic ion, simply write the name of that polyatomic ion. Simply write the name of that polyatomic ion from the list of polyatomic ions you are going to memorize. If the cation, the metal, can have more than one possible charge, meaning it's a transition metal, write the charge as a Roman numeral in parentheses. So if it's a transition metal, it must have the Roman numeral in parentheses. Let's talk about Oxyanion nomenclature. This is dealing with polyatomic ions, polyatomic oxyanions. When there are two oxyanions, meaning there are two polyatomic ions that contain oxygen, involving the same element, the one with fewer oxygens ends in ITE. For example, I've got two examples on the board. NO2 1- and SO3 2-. Nitrite has less oxygens than nitrate, being NO3. Sulfite has one less oxygen than sulfate in this next molecule. So the oxyanion with more oxygen ends in ATE. So this is when we have two oxyanions. Okay. What if we have four oxyanions? Well, the one with the second fewest oxygens ends in ITE. And typically you're going to see this with halogens. And our example is chlorite. The one with the second most oxygens ends in ATE. ClO3 is chlorate. And typically the chlorate is the common or the representative oxyanion. It's the most common one that you are going to see. Now, remember we have four. The one with the fewest oxygens, so in our example here, in our chlorate example, if you will, the one with the fewest oxygens, the one that only has one oxygen, has ITE, but it gets the prefix hypo, and the one with the most oxygen still ends in ate, but it has a prefix of per. So we would end up with perchlorate. Easiest way to do this is just to memorize that list of polyatomic ions. Acid nomenclature. Alright, we know that it is an acid if it starts with hydrogen. Alright, a few simple rules for acid nomenclature. If the anion in the acid ends in IDE, change the ending to ic and add the prefix hydro. Okay, so if it's a binary acid, meaning it only has two elements present, we're going to add the prefix hydro, change the ending to ic, and add acid on the end. Examples of this include hydrochloric acid. These are all, they would be chloride, so the IDE will become ic. Alright, if the anion, this is dealing with polyatomic anions or oxyacids, if the anion in the acid ends in ate, for example, chlorate, change the ending, the AT ending, to ic. So we would have chloric acid. Or if we have ClO4, our perchlorate anion, we would have perchloric acid. We're going to change that ATE to IC. If the anion, the polyatomic anion, ends in ITE, we're going to change that ending to OUS. So in hypochlorous acid, or the hypochlorite anion, the ITE becomes OUS. And in the chlorite anion, that chlorite becomes chlorous. And since it's an acid, we know it's an acid because it starts with hydrogen. It ends in acid. Nomenclature of molecular binary compounds. Molecular compounds share electrons and they form between nonmetals, or between a nonmetal and a nonmetal. We typically put the less electronegative element first. Okay, you should have that chart of electronegativity from Chemistry 1. Remember, fluorine's the most electronegative. All the way down, cesium and francium are the least electronegative. The prefix, or a prefix, a Greek prefix, is used to denote the number of atoms of each element in the compound. Okay, so for example, mono, di, tri, tetra, penta, hexa, hepta, octa, nona, and deca. Now we always omit mono on the first element, okay, because we can assume that it's there. But the second element, it is required if you have mono. Alright, the ending on the most electronegative element should be changed to IDE. So carbon, we have one of them, so it would be monocarbon. Remember, we do not use the mono prefix. So it would be carbon, and then we have two oxygens, dioxygen, but then we change the ending to IDE, carbon dioxide. Carbon is the first element, oxide is the second, or oxygen is the second, and we have two of the oxygen. Second example is carbon. We have one carbon, so we do not put the mono. Chlorine becomes chloride, and we have four of them. Four of them corresponds to tetra. Quite simple, the nomenclature of binary compounds. If the prefix ends with an A or an O, the name of the element begins with a vowel. The two successive vowels are often elided into one. For example, we have two nitrogen, so dinitrogen, 5 oxygen, so we have oxide. 5 is penta. We're not going to have pentaoxide. We're going to get rid of one of those. So we would end up with pentoxide. Dinitrogen, pentoxide. Pent meaning 5 oxygens, di meaning 2 nitrogens. And that's molecular nomenclature.